Today we're going to start our discussion on factoring. And when we talk about factoring, we want to remember that factors are quantities that are multiplied together to form a product. When you are starting math, you talk about factors of, for instance, 6. 2 times 3 is 6, and therefore 2 and 3 are both factors of 6. So that's what a factor is. It's a quantity that's multiplied together to form a product. So we want to look at this first example. We want to factor the following expressions. So as we look at factoring 3x squared minus 6x, the first thing we always check for is a common factor that's in each of them. So as we look first of all at the numbers, 3 and 6, we can see that we can factor out a 3 because 3 is in both of them. When we look at the letters, the variables, x squared and x, we can see that they both have an x in them, so we can factor that out as well. Now one thing to remember is when we factor out, we're really dividing. So what we're doing first is 3x squared, and we're dividing out 3x. So 3 divided by 3 is 1, x squared divided by x is x. And so in that first term we just have x minus, and then 6x, we divide out a 3x, and what's left there is 2. So our answer when we factor that one is just 3x times x minus 2. And the second one, for part B, we've got 3 terms. But again, the first thing we check for is a common factor. So between the 8, 6, and 2, we know that we can factor out a 2. When we look at the x's, we've got x to the 4th, x cubed, and x. We can factor out 1x from each of those. When we look at the y's, we have y squared, y cubed, and y to the 4th, so we can factor out y squared from each of those terms. So again, now we're dividing out. 8 divided by 2 is 4. X to the 4th divided by x is x cubed. And y squared divided by y squared is just 1, so that's our first term. Plus, 6 divided by 2 is 3. X cubed divided by x is x squared. And y cubed divided by y squared is just y. And then finally, for our last term, we have 2 divided by 2 is 1. X divided by x is 1. And y to the 4th divided by y squared is y squared. So our answer there for that one, we factor out each of those terms. There's nothing else that we can factor out, and that gives us our answer for part B. Remember that we always want to look for a common factor first when we're trying to factor. Even if it factors some other way, this is always going to make it easier for you to factor, and it'll give us smaller, or more simplified factors to work with. Okay, to factor the next one, notice here is one piece, here's the other piece. Oh, let me get rid of, well, we'll just ignore this temporarily and pretend it's not there. But notice each of these has an x minus 3 in it. So what we're going to factor out first is x minus 3. Now we do need to keep that in parentheses just like you see it there. What's left is 2x plus 4 minus 5. Now if you look at that, we can simplify the stuff inside of the brackets. So we still have the x minus 3, but inside the brackets we've got 2x, and then we've got 4 minus 5, which gives us minus 1. So to factor that one, we get x minus 3 times 2x minus 1. Now we'll get that cleaned off. When we're factoring trinomials, we want to remember that when you multiply two binomials together that are in the form x plus r times x plus t, the way you get the x squared is you multiply x times x. The way you get the last term, we want to jump to this one. The way we get this last term is we multiply the r times the t. So the product of those last two pieces gives us rt. One thing that's interesting is the middle coefficient is always the sum of those two last pieces. So if you notice, this b term here is the sum of r and t. The c term is the product of r and t. So r and t give us the important information about b and c, and that's what we're going to be looking at when we factor these, is we have to think about what will multiply together to be that last term and add together to be the middle term. For example 3, we want to factor this thing. The first thing we look at is this and the fact that there's no number in front of the x squared. That tells us we're going to use our, or the simplest option is to start out like this to see if we can factor this just with two parentheses beginning with x. The next thing we look at is this sign. This sign being positive tells us that the values, or the signs I mean, that go here and here have to be the same. The reason for that is that in order to multiply two numbers together to get 12, they're either both positive or they're both negative. A positive times a positive is a positive, and a negative times a negative is a positive. So the second thing we look at is this sign, because these two values have to add up to be a positive 7. So since we know they're the same, and we know they add up to be a positive number, they're both positive. So that tells us we can put x plus and x plus. They're both going to be positive. So now we simply write down the factors of 12 that are both positive. 1 and 12, 2 and 6, 3 and 4, and those are the only three options. So when we think about all of those or multiply together to be 12, but we want to figure out which ones add together to be 7. And so we can see very easily that the 3 and the 4 add together to be 7, and that's what's going to go in here in our parentheses to help us factor this. So the factorization of x squared plus 7x plus 12 is x plus 3 times x plus 4. Example 4 is a little bit more difficult because notice on this one there is a number in front of the x squared. So we actually have a little bit longer process that we have to go through. The first step here is to multiply the leading coefficient, 6, times the constant, which in this case is negative 5. And that gives us negative 30. The next step is very similar to what we've done before. We look at this sign, which is negative, and the only way to get a negative when you multiply two numbers together is, that means these have to have different signs. We still go back to this one then, and since we know they have different signs, this one tells us the positive one is larger. Wow, that looks horrible. Let's fix that word. The positive one is larger. There we go. So we're going to find factors of negative 30 that will add up to be 7, where the bigger one is positive. So negative 1 and 30, negative 2 and 15, negative 3 and 10, 4 doesn't go into 30, negative 5 and 6. So those are the four options that we have. And again, when we think about adding them together, the one that will add up to be 7 is the negative 3 and the positive 10. That's our second step, to figure out the factors that will work to add up to be 7. Our third step is this. We actually rewrite the polynomial here. 3x or 6x squared But instead of writing 7x, we write minus 3x plus 10x minus 5. And we use those factors that we just found to replace the 7x. The reason that we can do that is negative 3x plus 10x equals 7x. So we're not changing the problem, we're just changing what it looks like. Our last piece here is now we do a process called factoring by grouping. So we take the 6x squared minus 3x, and we put that in a group. And then we take the 10x minus 5, and we put that in a group. Now we look at each group and say, what can we factor out of the first group? And we can factor out a 3x. And what's left in there is 2x minus 1. Remember that we're dividing that 3x out. In the second one, notice we can divide out a 5. And what's left there is 2x minus 1. So notice, now we can factor out a 2x minus 1 from each of those. So we factor out a 2x minus 1. And what's left? 3x plus 5. And that gives us the factorization of 6x squared plus 7x minus 5. So when there's a number in front of this x squared like this, the process is a little bit longer, but it's still very doable. You just have to write down the factors and pick the ones that will work, and then factor by grouping. Some quadratic patterns. If we look at an example here, this first one is very easy to factor. We do our two parentheses, x and x. Again, this tells us the signs are different. And this one tells us now that the negative one is larger. So factors of 3, you've got the negative one larger. The only option we have there is 1 and negative 3. And that does add up to be negative 2. So plus 1 and minus 3. That's how we would factor that one. So as we look at example 5b, what's really happening here is, notice we have 5a plus 1 and 5a plus 1. We could rewrite this as a squared minus 2a minus 3. Notice it has the exact same format as 5a did. So that means it factors as a plus 1 times a minus 3, since that's how the top one factored. But we weren't trying to factor this polynomial. We were trying to factor that one. So instead of having those a's, what we need to have is 5a plus 1 plus 1 times 5a plus 1 minus 3. And then, of course, we should always simplify if we can. So this is 5a plus 2 and 5a minus 2. Because 1 plus 1 is 2, and 1 minus 3 is negative 2. So that's the factorization there. It actually ends up being something that's the difference of squares, but you would have never noticed that from the beginning. But this is what we call a quadratic pattern, where we can make this simple substitution and replace that piece with something else so that it factors very nicely for us. Some special factoring formulas. Some of these I don't really want you to even focus on a whole lot, but there are some that are very useful. The first one is one of the very useful ones, and this is what we call the difference of two squares. If you have something that's written as a squared minus b squared, or can be written as something squared minus something else squared, it will always factor in this way, as the first term minus, or plus the second term times the first term minus the second term. And that's one that we do a lot of. The second is what we call a perfect square trinomial. I don't spend a whole lot of time with this because by the time you recognize it's a perfect square, you can just factor it the way we've already learned. The same thing for number 3. This is a perfect square trinomial, and the reason they call it that is because your answer is a perfect square. But again, don't spend time trying to recognize that pattern. Just go ahead and factor it the way we've already learned. The difference of 2 cubes, this is one you are going to want to know. A cubed minus B cubed, again, if you can write it as the difference of 2 perfect cubes, it will factor in this way. And then the sum of 2 perfect cubes is there as well. So really number 1, number 4, and number 5 are the ones I'm going to want you to focus on for learning. And number 1 should definitely be memorized. 4 and 5, I will probably give you those. So you have to know how to use them, but you don't necessarily have to memorize them on the for the test. So when we look at example 6 here, we've got 4x squared minus 25. This squared right here is a hint when there's only 2 terms and it's squared. It's a hint that this is probably the difference of squares. So what we want to think of is, can we write this as 2 things that are perfect squares? So we want to think, what squared equals 4x squared? Well, if we think about the 4, 2 squared is 4. If we think about the x squared is x squared. When we go to the 25, what squared is 25? That one's pretty easy. 5 squared is 25. So once we've written it like this is like the a value, this is like the b value. A lot of times again, I'll say first term, second term. But that factors as the first term minus the second term times the first term plus the second term. So 2x minus 5 times 2x plus 5. The order there doesn't matter. If you put 2x plus 5 times 2x minus 5, it's the same thing. Looking at part B, this one's already set up for us. This whole thing is A, first term. This whole thing is B, the second term. So we can just write this as the first term minus the second term times the first term plus the second term. And that gives us our answer on that one. So that one was already set up as a perfect square. We didn't have to do any work with it to rearrange it. Now this one, again, it's a binomial, 2 terms, but it's got a 3 there. So that's a hint that this is probably either the difference of cubes or sum of cubes. And since we've got a negative, that tells us it's the difference of cubes. If we can write it as something cubed minus something else cubed. So what cubed is 27? That's what we want to think about, and that is a 3. And then we know that x cubed will give us that. What cubed equals 1? Don't make that complicated, it's just 1. So this would be our first term, this would be our second term, and we're just going to follow that pattern. The pattern is the first term minus the second term times the first term squared plus the first term times the second term plus the second term squared. Now, of course, we want to simplify if we can. That one just stays. But what is 3x squared? Remember, that's 3x times 3x, and that gives us 9x squared. Plus 3x times 1 is 3x, and 1 squared is 1. So there's our answer to part A. Part B, this one's a little bit trickier because it doesn't look like, we don't see a cube here. But again, can we write it as something cubed? 2 cubed is 8, so that one's pretty easy. But you want to think about what times itself 3 times equals x to the 6th, and there actually is something, it's x squared. So this is the sum of two cubes. There's our first term and second term. And we just follow the pattern. First term plus second term. Remember, this is a different pattern because this one was a subtraction and this one was a sum. So it's a slightly different pattern, but still very similar. First thing squared minus the first thing times the second thing plus the second term squared. So again, we have to simplify that second piece. X squared plus 2 stays the same. Then x squared squared is x to the 4th. X squared times 2 is 2x squared. And then 2 squared is 4. So that gives us our answer to part B. Now again, we want to remember the first thing we always look for is there anything we can take out of both terms? So in this case, notice we can take out a 2 and we can take out x squared. And once we do that, here's what's left. Take out the 2, you divide out the x squared, you're left with x squared minus 4. X squared minus 4 is a difference of squares. So notice this is x squared minus 2 squared. So that's our A and that's our B. So when we factor this, we're going to have the 2x squared has to stay there. Then we're going to have first thing x minus second thing 2. And first thing x plus second thing 2. And so that's our factorization on that one. Always factor something out first if we can. For part B, we can factor out an x from both of those. We can also factor out y squared from both. And so we'll be left with x to the 4th minus y to the 4th. So, it may not be obvious, but this is x squared squared minus y squared squared. So there's your A value, there's your B value. So let's go up here and keep going. We've got xy squared still. Then we're going to have x squared plus y squared times x squared minus y squared. And again, that's just following the pattern. First thing plus second thing, first thing minus second thing. As we look at this, we don't have a pattern for the sum of squares, so we can't do anything with that. But we do have, think of that as A and B, we do have a difference of squares again. So the first stuff is just going to stay the same. xy squared, x squared plus y squared. And then here we're going to use that pattern again. The first piece is just x, minus the second piece is y, and then x plus y. And that gives us our answer for part B. So factoring out a common term and then the difference of squares twice. When we look at a problem like this, it looks horrible. But again, if we factor out a common term, notice they all have a 3 in them. So we can factor out the 3. They also all have x to a power. And if you've noticed, we've always factored out the smallest power of x. So the smallest power of x that we have in this case is x to the negative 1/2. And that comes from right here. That was our smallest power of x. So in the first term, when we factor out the 3, the numbers are gone. But what happens when we factor out x to the negative 1/2? Well, if you remember your rule, when you divide, you subtract the exponents. So just off to the side here, what is 3/2 minus negative 1/2? Well, remember when you subtract, that's the same as, use your change it rule, that's addition. That's 4/2. But that's a 2. So this is really x squared minus 9 divided by 3 is 3. Now this is going to be the same thing, but it's 1/2 minus a negative 1/2. Changes it to adding, you get 2 over 2, and that's a 1. So that's just 3x, and then plus 6 divided by 3 is 2, and we factored out that x to the negative 1/2 already. So we factored out a common term. Now this looks like something that we might be able to factor. There's no number in front of the x squared, so we'll just leave 3x to the negative 1/2, and then we'll try and factor it using the method that we've already learned. We'll put an x in the front of each of those parentheses. And this tells us the signs are the same. Then this tells us they're both negative. So minus and minus. And we need factors of 2. Well, there's only one set of factors of 2, negative 1 and negative 2. And fortunately for us, they add up to be negative 3, so they will work. And since they work, that's our factorization. 3x to the negative 1/2 times x minus 1 times x minus 2. One more problem that's pretty similar to this. Notice we've got 2x plus 1 raised to the negative 2/3 and 2x plus 1 raised to the positive 1/3. So we factor out the 2x plus 1 to the lowest power. Or sorry, 2 plus x, to the lowest power. And the lowest power here is the negative 2/3. So then, what's left? Well, we factored this piece all out. That's gone. So all we have left in that first term is x plus, we're going to have 2 plus x, but the question is, what power is that raised to? So again, we have to use our rule. We're dividing out the negative 2/3. So that means we subtract the exponent, so 1/3 minus negative 2/3. We end up adding, and we can see 1/3 plus 2/3 is 1, so that's just going to be the first power. So the 2 plus x to the negative 2/3 power will just stay there. And like always, we want to simplify if we can. So notice, we can simplify this. It's x plus 2 plus x, and that is 2x plus 2. And actually, there's one more thing we can do. Notice we can factor out a 2 from each of those. So this ends up being 2 times 2 plus x to the negative 2/3 times, and remember we factored out a 2 from here, so x plus 1, we divide out that 2. So there's our answer for B. Those are all the examples that I've got for you today. Factoring hopefully is review. We spend a lot of time on it in Algebra 2. But again, as you're working through these, if you have questions, we'll go over those questions tomorrow in class and answer any questions that you might have. Again, I'll do 2 or 3 on the board, and then you'll have time to work by yourself and ask individual questions. So